Hello and welcome to KidWind, our Wind Design Challenge for students grades 7 through 12. We're excited to kick off another school year with you. In this video, we're here to explain the curriculum, the materials, the calendar, and introduce to you our newest platform, Canvas, for the Wind Design Challenges this year. For our alumni, welcome back. You will see the name of your kit has been changed simply to Alum. This will avoid confusion in future years. Below is the list of the materials you will receive in this year's kit. For our new teachers, welcome. Below, listed under New, is a list of all of the materials that will be coming to your school. Every teacher will have access to our materials. In our student resources, we will have student data sheet as well as the pre and post poll. For teacher resources, we will include the unit plans, videos on how to set up the turbine, as well as videos including supplementals you can use in your classroom, calculations breakdown, teacher evaluation. The next few slides will lay out a few of those resources for you.
Hi, this is Abby from the Ohio Energy Project, and today we're going to explain how to create and build the tower for KidWind. So we're going to be creating something, of course, that looks like this, and I'm going to show you how to do the base. The first thing you do is you're going to grab the bottom of the blue base and then the feet, and you just clip them into place. So they're just going to slide in and click. That's how to complete the base. So the next thing we're going to be doing is building the nacelle and the top part of the tower. So to build the nacelle, what you're going to do is use your 3 pieces of PVC pipe. So I'm going to grab these, the smaller piece, put it in. The next piece I'm going to fit into place. The nacelle is what holds your motor for the top part of the tower. So you will feed the motor through. You're going to feed the wires through the back, the PVC pipe. So they're going to come out the back end like so. And so we already have it started for you, but what we would recommend is getting tape to make this motor fit a little more snug. You want it as snug as possible. So we've started it for you. You can use masking tape, duct tape. So just kind of fit it around the motor. And then once it is in, make sure it fits nice and snug into that PVC pipe. Then you're going to take your tower, put it into the bottom of the nacelle, and then with the blue piece, put it at the end of the tower, and then pop it directly into your base. Okay, so you're going to take the wires that come from the motor and you're going to wrap them around the tower. We're gonna do this so they don't get kind of caught up in that blade. So we want it at the back end. The leads are going to be facing the back end of the tower, and it's good to just tape it down. We want some of these leads to be kind of hanging off of the tower so that we can make that connection. So when you get your wires, you will see that they will need to be stripped, similar to how the black one has been stripped, so simply just strip them. From here, what we're going to do is we're going to attach our alligator clips. So with one alligator clip, we're just going to touch the wire, grab the other one, attach it to the wire, what we are measuring is the voltage across the resistor. So now we're going to work with the digital multimeter. What we're going to be doing first is we're just going to be checking. We've got our off and on switch here, and then we're going to be staying in this upper left window. We're going to be looking at the DCV, which stands for your direct current voltage. What you would want to have your students do is stay on the 2000 millivolts. This is going to give you the best accuracy for your design. So the next thing you're going to do is take your black and red jacks, and you are going to put the black one into the COM, which stands for common. The next thing that you're going to do is you're going to take your red jack and you're going to put it in the one right above it, which has the V for volts, and then of course for the resistor, the ohms, and plug that one in. Next thing you could do is turn on your digital multimeter. To move on to the beginning of testing. So a student would come and take their design that's on the hub and put the hub onto the motor. So we've kind of explained and demonstrated that for you. A good rule of thumb is that the center of the hub should be at the center of the fan. So you want to make sure also that your students know the distance between the fan and the hub. They will need to record that on the wind speed chart. Also, before you begin, it's very important to make sure that your fan is secure. So we have the multimeter hooked up, and if you're seeing, we're touching the probes to the resistor, and we're seeing a reading. Right now, you're going to be recording the highest number that you see. We're looking at the multimeter and seeing that it's negative. That's just due to the polarity, so we simply switch the probes. You will see that similar number, but now in positive. We are in millivolts reading this. Your students will need to convert it to volts, of course just dividing by 1000. KidWind Challenge is a hands-on approach to learning renewable energy. Students can work individually or in teams to create a wind turbine with the goal of producing the most power. Students will earn points on efficiency, creativity, and power of their piece. In this curriculum, students will get a pre- and post-poll to assess their knowledge throughout the program. The goal of the program is to take the students, teach them the engineering design process by creating the wind turbine design. New to KidWind this year is our learning management system, Canvas. This platform will house all of KidWind's files. After watching this video and filling out the questionnaire, you will receive an email from one of our education coordinators regarding Canvas. Soon you will see, as the arrow shows, a KidWind published course. In this course, we will have everything laid out for you, beautifully and easily to follow in order to explain to your students. In the teacher resources will be laid out a setup video, as well as unit plans if you choose to use. Under student resources, we have our student data sheet and the student pre- and post-poll, each having a PDF or a Word document if you choose to edit. Also available on Canvas are our supplemental resources, anything that we felt was important to drive that curriculum home. Attached is information on the boy who harnessed the wind, as well as any of the resources and curriculum from the KidWind website itself. Thanks so much. For any questions you have, please don't hesitate to reach out. All our resources can also be found at ohioenergy.org.